Hello there, Mr. Sutton here. I've got the Pre-Cal Honors 3-5 Extra Practice Number 2 solutions on rational equations. For this problem, given this rational equation, they want us to find the value of x squared. Well, before I can even think about finding the value of x squared, maybe I should move in the direction of finding the value of x. To do that, since I've got a rational equation with all these fractions and denominators, I want to get rid of the denominators. The easiest way to do that is to multiply all the fractions, all the terms really, by the least common denominator. The LCD, that has everything I'm going to need to cancel out each of these denominators. So my LCD needs a 5, it needs an x minus 2, and for this one it needs an x plus 2. Let's go ahead and multiply each of the numerators by that now. So my first fraction gets multiplied by the LCD. My second fraction gets multiplied by the LCD. And this 8/5 gets multiplied by the LCD. Seems like an awful lot of writing, but the reason I write all of this out is because I'm going to be canceling different things out, and I need to know what's left over from the LCD after I do that. Okay, so for my first fraction, the x minus 2's cancel, and the x plus 2's are canceling in that next one, and the 5's are canceling in that last one. So now I'm going to go back through and multiply things out and pick up the pieces and see what kind of equation we're dealing with. Now the whole point of this was to get rid of those denominators, so I've at least done that. For my first fraction, I still have this 5 left over along with an x plus 2 and this 1 that's really making no difference at all. Distributing the 5 though, we've got 5x plus 5 times 2 gives me 10. For the next fraction, I have a 5 and an x minus 2 left over, and again another 1 that doesn't make a whole lot of difference there. We have to be careful though because this is a negative going on. This negative applies to this 5 here. So I'm really distributing negative 5 to both of those. I end up with negative 5x, and then negative 5 times negative 2 is positive 10. It's got to be careful there. And now last but not least, we have the x minus 2 and an x plus 2 and an 8. That's a whole bunch of stuff. I'm going to start by multiplying the parentheses together here. Since these are conjugates, same terms but opposite signs, I can use the a squared minus b squared shortcut. So we have the x being the first term being squared, so x squared, and then 2 squared is 4, and I put a minus in the middle, so x squared minus 4. And then I can't forget about that 8 that's still hanging around that I'll deal with in just a moment here. All right, so let's continue to clean up this equation. On the left side, I have a 5x and a minus 5x that can cancel out. The 10 and the 10 can add together to give me 20. That's all that's left on the left side, so that's nice. On the right side, I can distribute this 8, so that's 8x squared minus 32. And I can get the 8x squared alone by adding 32 over there, so that's 52 equals 8x squared. And I can get x squared by itself if I divide by 8. But now 52 over 8, I can actually reduce that by 4. That's going to be, let me think here, 13 over 2. And before I go ahead and square root this and then square the answers, we were looking for the value of x squared, not x. Well, look at this. We have x squared equals a number. So I'd say we're done. For this problem, we're being asked to solve for x in this rational equation. Now, since this one is just one fraction equaling another fraction, we can just use cross-multiplying for this. So if I do x plus 2 times the 1, that gives me x plus 2 on the left side of the equation. And if I do 2x minus 5 times the right side here, 2 times 2x minus 5, I have to distribute that. That's going to be 4x minus 10. And then let me just move the x's over to the right, the constants over to the left, just so I'm getting a positive number here. So we've got a 3x on the right, a 12 on the left. And if I divide both sides by 3, I get x equals 4. Just double checking, if I plug 4 back in here, it doesn't look like that's going to make anything 0 in the denominator, no undefined. So 4 then is our final answer. And there wasn't an answer choice for no solution anyway. For this multiple choice question, we're given that b plus c over c equals 14 over 15. And we want to know which of these is true. So these are all statements where we have b over c equaling something. So this is kind of a mess. You might be wondering, how do I even proceed here? So probably the easiest way to go about this is to just cross multiply and hope for the best. So if I do that, 15 times b plus c gives me 15b plus 15c. And then crossing the other way, we have c times 14, so 14c. And I see here now that I can actually combine these c's together, which will be kind of nice. So subtracting 15c from both sides, that's going to be a negative, let's see here, negative 1c on the right side. And if I want to get, let's see, b over c, well, it'd be helpful if I didn't have this 15 next to the b. So I'll divide both sides by 15 to get, well, actually, let me move the c over here. If I want to get b over c, I need to have b divided by c. So let me start by dividing by c. That will give me 15b over c equaling just negative 1 over there. And now to get b over c, I actually just have to divide away this 15. That'll give me negative 1 over 15 on the right side. I've got b over c on the left side now, which is what I was looking to isolate. So it looks like my answer then is choice C. For this problem, this is kind of a weird question. They're asking how many solutions exist for this equation. So although we don't technically need to solve for what the solutions are, that is definitely one way of figuring out how many there are, is just to solve them and count them. So probably the fastest way to get going on this problem is to get rid of this fraction by multiplying x plus 3 to both sides. So let me just move it over here with the x minus 2, and I'll put the x minus 2 in a parentheses just so I don't lose anything when I do that. Now let me just multiply things out, FOIL them out, simplify, distribute, all that stuff, and maybe get everything over to one side if I need to. So on the left side, distributing my x, I've got an x squared minus 1x. I still have a negative 6 over there. On the right side, I'm going to FOIL the x minus 2 and x plus 3. Firsts gives me x squared, outers gives me 3x, inners is a minus 2x, and the last's negative 2 times 3 is negative 6. Now I'm going to see if I can get everything on one side. So I've got an x squared on the left. Let me subtract the x squared. That actually completely cancels out the x squared, so that's kind of nice. Let's see here. I've got a negative x, and over on the right side here I have a positive x if I do 3x minus 2. If I subtract that positive x to be with the negative x on the left side, I now have negative 2x over on the left side. And the 6 is actually, if I add 6, those are going to cancel, and I'm just going to be left with 0 on the right side and negative 2x on the left. If I divide now, we just get x equals 0, and that is just a single solution. Let's just plug that back in just to be sure. If I plug in 0, that doesn't give me 0 in any denominators, so we have one solution total then, which means we're going to pick answer choice B.